Hey guys, so we're going to learn a little more about circuits now and um, how the current flows and how the current behaves in circuits. Okay, so first thing we're going to do is just look at a simple series circuit. Okay, so I'm going to make this fairly simple numbers and things like that. I got 3 resistors here in series. Let's make this one 3 ohms. We'll make this one 6 ohms. And then I'm going to make this one here 9 ohms. All right. Now, what we have to do from here is we're going to figure out how much current's flowing through the circuit. So there's a law for that. It's called Ohm's law. Ohm's law helps us to figure out how much current is flowing. It also provides us with a relationship between voltage, resistance, and current. Okay, so I am going to make this 36 volts. Okay, so Ohm's law, you'll see it written as V is equal to IR. So if we have the voltage and we have the resistance, we can find the current. If we have the current and the resistance, we can find the voltage. Now, the voltage across the battery here is 36 volts. What we could do is we could find the voltage drops across each resistor, because basically what we have is we have the battery giving energy to the electrons that then are pushed through the circuit. The electrons, when they leave, are carrying 36 joules. Now wait, that's each coulomb of electrons have 36 joules of energy. And as they go across these resistors, they are losing some energy to the resistor. The resistor then takes that energy and turns it into thermal energy in the form of heat. Okay, so here's what's going to happen. We're going to use Ohm's law to find the overall current flowing through here, and then we're going to show the voltages across each resistor, and then we're going to make some conclusions and things, and it's basically going to explain what you have in your textbook on page 527. Okay, so you can look at page 527. And it's going to explain some of the voltage drops in series and how that works. Okay, so RT in this case is going to be 3 plus 6 plus 9, because they're all in series. So we have 18 ohms. Now, here's Ohm's law. It can be rearranged a few different ways. We got I is equal to V over R, and we got R is equal to V over I. Now, any one of these 3 formulas, what you can do is you can add in subscripts. So I'm going to take the one that says I equals V over R, and I'm going to change this. I'm going to say IT. Now, what does IT stand for? It stands for total current. VT. So if I put a T here, I'm going to put a T with everything else. Okay? So that's one of the rules. If you write that formula down and you put a subscript, I want to see that same subscript for each thing. Okay? Now, here's what we'll do. So IT, that's our total current. IT is going to be equal to, what's VT? Well, that's the applied voltage of 36 volts. What's RT? Well, we just found that is 18 ohms. So I told you I was going to make the numbers work out nice. This gives us 2 amperes of current, or 2 amps would be the slang way of saying that. So our total current is 2 amps. We have to think about and remember what current is. It is the rate at which the charges are flowing through the circuit. So 2 amperes means 2 coulombs each second. So we have 2 coulombs of charge flowing through here each second. So in 5 seconds, that would be 10 coulombs of charge would have flown through this circuit. Okay, that's an extremely large amount of charge, but that's what we deal with when we're dealing with electric circuits. So here we go. So we got the 2 amps. It has to go through the 3, it has to go through the 6, and it has to go through the 9. So in a series circuit, current is constant and the same everywhere. Here's 2 amps, here's 2 amps, here's 2 amps, here's 2 amps, here's 2 amps. It goes through everything. So in series circuits, current is the same everywhere. What is different is the voltage drops. Okay, so we are going to figure out, now I should have labeled these. So R1 is this is R2, and this is R3. Okay, so I want to find what the voltage drop is. So how much energy we're losing across this one, and across this one. So V1 is equal to I1 times R1. Now in this case, you could also call this IT, because the current going through resistor 1 is the same as the current going through resistor 2 is the same as the current going through resistor 3. So I'm going to call it IT times R1. So V1 is going to be 2 times 3. So we get 6 volts here. V2, what's that? Well, V2 is going to be I2 times R2. Well, I2 was still 2 amps. It's 2 amps everywhere. So it's going to be 2 times 6 is 12 volts. And then let's look at V3. So V3 is going to be I3 times R3, just from the formulas above. I3 is, well, it's 2 amps again, times 9. That gives us 18 volts. Now what's interesting here, and what conclusions you can learn from this is, well, if we add up these 3 voltages, 6 plus 12 is 18, plus another 18 is 36. So in a series circuit, the voltages, or the total voltage, is equal to the sum of all of the individual voltages. So V1 plus V2 plus V3. So later on when we do problem solving, you might see a circuit. They might tell you the current, they might tell you the voltage drops across some of the resistors, but they won't tell you the total voltage or all of the values of the resistance. Okay, so you can use these facts to determine other things in the circuit. Now that we have the voltage drops, you'll also notice a couple other patterns. It's proportional to the resistance. So in a series circuit, the biggest resistor will get the biggest voltage drop. Okay, so the 9 ohm had an 18 volt drop, whereas the 3 ohm only had a 6 volt drop. All right. So just to summarize what we learned, in a series circuit, we add the voltages. They should add to the total. The current is the same everywhere. Next video, we're going to look at a parallel circuit.